Alright, so the triangle proportionality theorem says that if a line parallel to one of the sides of a triangle, so for example, here we got a triangle ABC, and we've got this line segment DE, it's part of a line that's parallel to this side AB. If a line parallel to one of the sides of a triangle intersects the other two sides, so intersects, it divides those sides proportionally, which means, okay, so line segment AB is parallel to line segment DE. By this theorem, therefore, three dots, therefore, because of this theorem, we can conclude that the ratio of the length of AD to DC is equivalent to the ratio of BE to EC. That's what proportionality means. If two ratios are proportional, that means they are equivalent. They have the same value. Right. So we're talking about ratios of parts of sides of a triangle. So let's make some more sense of this by applying it to an example. So here I have another triangle, ABC. I'm very imaginative with my triangle naming, right? That's standard. Okay. So line segment DE is parallel to BC. Okay. So it's intersecting these sides. So we know that the proportionality theorem applies. So we know that this line segment makes it so that the length of BD as compared to the length of DA is proportional to the length of CE compared to the length of EA, right? So if AE, I called it EA, either way, AE is equal to 5x, EC equals 1x plus 6, AD is 60, DB is 18. How can we apply this theorem and this information that we're given to figure out first what x is and then what the lengths of AE and EC are? Well, so the length of this divides the sides proportionally. So the ratio of this length, let me color code it. I think that would be a good idea. The ratio of that side or that segment to this segment. So I'm gonna symbolize that like this. The ratio of that segment to this segment is equivalent to the ratio of this segment to this segment. Yeah? Okay. You feeling this so far? So, AE equals 5x. Now let's just label that. Why not? Let me go green. 5x. AE is 5x. EC is 1x plus 6. AD is 60. DB is 18. So by this theorem, the ratio of 60 to 18 is equivalent to the ratio of 5x to 1x plus 6. Okay? So now we're living in algebra land. We can solve for x here. So this is a proportion, so we can cross multiply, let's say. So 18 times 5x is equal to 60 times 1x plus 6. Alright. So 18 times 5, what is that? 20 times 5 is 100. 2 times 5 is 10, so 90. Yeah, 90x. Check in the mental math. Got it. So 60 times 1x is just 60x. 60 times 6 is 360. Alright, let's solve for x. Let's get the x's together. I'm going to subtract 60x. 60x. So 90x minus 30x, or 60x is 30x. 30x is equal to, what we have left here, 360. I'm going to divide both sides by 30, so we can get x by itself. Divide by 30. So x is, what is that, 18? 36, no, 12. Sorry. 36 divided by 3 is 12. So x is 12. And therefore, AE is what? 5 times 12 is 60. 1x plus 6. So x is 12. 12 plus 6, 18. 60, 18, 60, 18. Get it? Alright. So I'm going to let you finish this problem, but I'll set it up. So, alright, actually, I paused this and looked at it. There's some ambiguity in the way I wrote that word problem, so we're not going to do it. So you're off the hook. Don't have to do that. So here's the process. So you get the basic idea that when a line segment is parallel to one of the sides of the triangle and it intersects the two other sides, then the line segments it creates on those two sides it intersects, the ratio of one to the other is equivalent to the ratio of one to the other. I hope you see where I'm pointing, because I'm not being specific in my words. So it divides those sides proportionally. That's what that means. So that you can use that fact to your advantage, and yeah, that's helpful. All right. Yeah. So have fun.